Your FastAPI app has startup logic, and your MCP server has its own initialization needs. How do you ensure both run correctly when combined? We'll implement a combined lifespan pattern that properly initializes both your FastAPI application and the mounted MCP server, ensuring clean startup and shutdown sequences without conflicts. The solution uses nested async context managers to maintain the correct initialization order. From ContextLib import Async Context Manager. From FastAPI import FastAPI. From FastMCP import FastMCP. Hash your existing lifespan. Add Async Context Manager. Async Def App Lifespan App FastAPI. Hash startup. Print starting up the app. Hash initialize database, cache, etc. Yield. Hash shutdown. Print shutting down the app. Hash create MCP server. MCP equals FastMCP. Tools. MCP app equals MCP. HTTP app path equals /MCP. Hash combine both lifespans. Add Async Context Manager. Async Def combined lifespan app. FastAPI. Hash run both lifespans. Async with app lifespan app. Async with MCP app. Lifespan app. Yield. Hash use the combined lifespan. App equals FastAPI. Lifespan equals combined lifespan. App mount /MCP MCP app. This demonstrates the composite lifespan pattern for integrating multiple asynchronous services. The technique combines separate initialization contexts into a unified lifecycle manager, ensuring proper startup and shutdown sequencing across independent components. What makes this distinctive is its ability to nest context managers, creating a hierarchy where inner services depend on outer services being ready first. The pattern works by treating each service's initialization as a self-contained context, then composing them into a parent context. The outer context, your application, initializes first, followed by inner contexts, like the MCP server, in a guaranteed order. This maintains separation of concerns while enforcing dependencies. The MCP server won't start until your database connections or caches are ready, and everything shuts down in reverse order. This approach solves the common problem of cross-service dependency management in async applications. It's particularly valuable when mounting third-party services like MCP servers into existing apps, where you need to preserve both the host app's initialization logic and the mounted services requirements. The trade-off is slightly more complex lifespan code, but the benefit is reliable service coordination without implicit timing assumptions. Let's break it down. From ContextLib import Async Context Manager. From FastAPI import FastAPI. From FastMCP import FastMCP. Imports the core dependencies. Async Context Manager for async lifespan management, FastAPI for the web framework, and FastMCP for creating AI-callable tools. This establishes the foundation for combining FastAPI's HTTP server with FastMCP's tool server in a single application. Add Async Context Manager. Async Def App Lifespan App, FastAPI. Print starting up the app. Yield. This implements FastAPI's lifespan pattern for application startup and shutdown. The code before yield runs once at server startup, perfect for initializing shared resources like databases or caches. The yield separates startup from shutdown logic, ensuring proper cleanup when the app terminates. Hash create MCP server. MCP equals FastMCP. Tools. MCP app equals MCP. HTTP app path equals /MCP. This initializes the FastMCP server instance named Tools, creating a dedicated HTTP application endpoint at /MCP. The separation between MCP and MCP app follows the FastMCP pattern, where the core server instance and its HTTP interface are distinct, enabling flexible routing and middleware integration.
Hash combine both lifespans. Add Async context manager. Async def combined lifespan app. FastAPI. Hash run both lifespans. Async with app lifespan app. Async with MCP app. Lifespan app. Yield.
This implements the lifespan composition pattern, combining multiple startup shutdown sequences into one. The nested async with blocks ensure both the main app and MCP server initialize and clean up in the correct order, preventing resource leaks. Critical for apps that need coordinated startup of multiple services.
Hash use the combined lifespan. App equals fast API. Lifespan equals combined lifespan. App mount /MCP, MCP app.
This instantiates the FastAPI app with our custom combined lifespan, ensuring both the main app and MCP server initialize and shut down together. The mount operation integrates the MCP server at the /MCP path, creating a unified API surface where both FastAPI and MCP endpoints coexist under the same server process. This pattern eliminates separate server management while maintaining clean resource lifecycle control. Lifespan integration pattern. The nested async context managers here demonstrate FastMCP's clean approach to resource initialization, where your application's startup logic and MCP's session manager coexist without conflict. The inner context, MCP, initializes after the outer context, your app, ensuring proper dependency ordering that's invisible to the client. This pattern scales from simple scripts to enterprise systems while maintaining the same initialization guarantees.
The context that yields nothing manages everything.